Hi everyone, in this video we'll be designing the car rental system. This is one of the popular question which is nowadays asked into various startups in India. So let's get started. So this is the flow that we would be following in each and every video in our low level design series. The first step is understand the system. And I believe this is one of the important step because let's assume that I ask you to design snakes and ladder and I also ask you to design Sudoku. Then the chances are high that you'd be able to design snakes and ladder because you have definitely played the snakes and ladder in your life. And the chances of you having played the Sudoku is comparatively less. So you might not know about Sudoku. Right. So if you don't know anything about Sudoku, then obviously you can't go to the next step. So that's the reason why we would always try to first understand the particular system briefly. Once we understood that system, we would go to the requirement gatherings part. And what I've done is, in order to simplify this requirement gathering steps, I have categorized that requirement gathering into three categories: extensibility, dynamic, and high traffic. So all the requirements related to extensibility will go into this category. So assume that currently your system has Stripe payment gateway and PayPal payment gateway. But in future, you might want to add some other payment gateways as well. So that requirement comes under extensibility because you might want to add something in the future. But while adding that, you don't want to modify the old code. So that requirement will come into extensibility. Similarly, let's say currently you are charging your customer based on time. But in future, you might want to charge your customer based on event as well. So this requirement will also go under extensibility category. The second category is dynamic. So all the requirements where user will provide the input will go into this category. For example, let's say we are playing tic-tac-toe. So over there, we can ask the size of the board from the user. We can also ask the number of players from the user. So all those requirements will go under dynamic category. The third is high traffic, or you can say concurrency. So assume that you have a website which allows the user to book a ticket. Now there is one movie going on and it has only one ticket available, I mean one seat available, and two users are simultaneously trying to book the seat. So obviously only one of them should get, isn't it? So that is the time when you have to deal with concurrency. Okay. So all the requirements related to concurrency will go under this category. So once you have written down all the requirements, your next goal is to write down the entities. So you would go through each and every requirements and write the corresponding entities. For example, let's say in this requirement, payment gateways requirement, the entities could be payment interface, Stripe payment gateway, PayPal payment gateway, payment status enum, etc. Okay. So you'd write the entities like this just for yourself. And once you have written down the entities, your next goal would be to connect those entities and try to understand the flow between those entities. Because if you don't even understand the flow, then obviously you won't be able to write the code. So in order to understand the flow, we would be drawing the class diagram. In an interview, you probably might not have access to the whiteboard, or maybe you won't have much time to draw the class diagram. So in that case, you can directly explain the flow. But in the LLD videos that I'm going to make, I will be explaining you the flow through the class diagram. Okay. And in the class diagram, I would be basically using these two kind of relationships. Either relationship is between class 1 and class 2 when class 1 is a child of class 2. Okay. And has a relationship is between class 1 and class 2 when class 2 is one of the attribute of class 1. Okay. So once we know the flow of our system, we would be easily converting that flow into working code. And these 5 steps basically would help you in your LLD round and in your machine coding round as well. Because the expectation in LLD round is to write down the requirements properly, to write down the entities, and to explain the flow to the interviewer. And in the machine coding round, the expectation is to write down the working code. And in all the LLD videos, we would be covering all these steps. That's why it would be helping you in your LLD and machine coding round. And by the way, I would be explaining this, or I would be embedding this particular explanation in each and every video for the first time visitors. But if you have already seen this particular part, 7 to 8 minute part, then you can skip that in all the other videos. Okay. So now let's begin with our current system. So let's try to understand this car rental system in brief. So assume that this is one of the branch of a car rental company. This branch is in New York, and that company also has one branch in Boston. Similarly, it has many more branches in different cities. And let's assume you live in New York and you want to rent a car. So there are 2 cars and 1 bike available in this branch at a moment. And you want to rent a car. Okay. So you would book a particular car, let's say this car, and you would drop that car to a particular drop location that you select. For example, you want to go to Boston, so you would select drop location as Boston. So this is all about the car rental system, which we need to know before proceeding to the requirement gathering part. So now let's move to the requirement gathering part. So I've already noted down all the requirements and I've categorized those requirements into these 3 categories: extensible, dynamic, and concurrency. So let's start with the extensible category. So in the interview, the first question that you can ask to the interviewer could be, what types of vehicles should the system support? Okay. So in the explanation that I did, I used car and bike. So this was just for explanation's sake. But in reality, there would be different types of cars, right? Sedan, SUV, etc. Then there would be different types of vehicles as well. I mean bikes as well. So that's what the interviewer is saying. There should be vehicles like sedan, hatchbacks, SUV, etc. And this system should be extensible enough to support more vehicles in future. Okay. So this was the first question. The second question you can ask is, how should a vehicle selection be handled when multiple options are available? So, so let's say you want to book one SUV. So this is one SUV and this is another SUV. So which of this SUV should be assigned to you? Either this or this. Now, again, there should be some algorithm, right, in order to decide this stuff. So that's what the interviewer says. Interviewer says that booking should support multiple ways, such as cheapest first and least booked vehicle first. So if this vehicle is booked 3 times, if this SUV is booked 3 times, and if this SUV is booked 4 times, and or your system supports least booked vehicle first, then this will be the vehicle which is going to be assigned to you because it was booked 3 times, which is less than 4. Okay. And it should be extensible so that in future you can add more algorithms as well apart from this two. Now the third point that you can ask the interviewer could be, will there be multiple ways to calculate rental charges? So let's say this vehicle was assigned to you, but then I have to take some money from this user, right? Then what should be that money? Should that money be based on the distance from New York to Boston or based on the number of hours? Okay, so this is third point. The system should support hourly based charging and distance based pricing. I mean hourly pricing and the distance based pricing. And it should be extensible so that in future I can charge the customer based on different criterias. Okay. And the fourth point you can ask is, now that we know that this is the money that we would be charging, but how should the user will be paying? Should the user be allowed to pay using UPI only, or it can support other ways as well, like credit card, cash, etc. So this was the fourth point, and obviously this payment method should also be extensible. Like in future, I can add more payment methods as well. Okay. So I hope you have understood all the 4 points in the extensible category. Now you can add more points for the learning purpose, but in the interview, I recommend you to keep less number of requirements so that you can complete the round in time. Now the requirements under the dynamic category. So if you remember, the dynamic category means the user or the admin will give the input. Okay. So the first point that you can ask is, should the system allow adding new branches dynamically? Yes, it should allow. Okay. Like I as an admin, or I mean I should be having different functionalities like update, delete, add. Basically I should be having CRUD functionality on the branches. And similarly, each branch would have many vehicles, right? So the same thing I should be having for that as well. Like I can add the vehicle, remove the vehicle, and so on and so forth. So this should be your second point. That is, should each branch maintain its own vehicle inventory? Yes, and you should be able to perform CRUD operation on that. So I hope you understood all the points in the dynamic category as well. Now regarding the concurrency part, the question that you can ask is, do I need to ensure that no two vehicles are booked simultaneously? So assume that there is only one bike available in this branch, and you and me, both of us are trying to book one bike. Then obviously one of us should get that bike, right? And that's what the first point in the concurrency says. And let's say the answer of the interviewer is yes. Interviewer wants you to handle this scenario. Okay. So I hope now all the requirements are crystal clear. So now let's try to note down each and every entities. So the procedure to note down each and every entities is very simple. You have to scan all the requirements one by one. So let's start doing that. The first requirement is, what type of vehicles should the system support? So this is one entity, and this entity can be further divided into sedan, hatchback, SUV, etc. And we can have one enum called as vehicle types. Okay. The second point says that how should vehicle selection be handled when multiple options are available. So what you can do is you can create or you can note down this entity which is booking. So this is one entity, and this is the good opportunity to use strategy design pattern over here. Why? Because currently, in order to book a particular vehicle, your system supports this two algorithm. But in future, if I want to add one more algorithm, I should be able to do that without modifying the old code. So that's the reason why we can use strategy design pattern. And if we are using the strategy design pattern, so obviously we would have one booking strategy and concrete booking strategies like cheapest first and least booking strategy. So total entities in the second point could be booking, then one interface, then cheapest first strategy and least booked strategy. Then the third point says that will there be multiple ways to calculate rental charges? Yes, there should be. So again, we can use strategy design pattern for the same reason that we discussed in the second point. And again, we would have one interface for calculating the charging. So we can have one pricing strategy interface and one hourly based pricing strategy, which is a concrete class, and one distance based pricing strategy, which is another concrete class. And they both will be implementing pricing strategy interface. And the fourth point is also the same, that is it will also use the strategy design pattern for different payment methods. So I think I don't need to explain this stuff again and again because this is going to be covered in multiple LLD problems, and I've explained this in the parking lot as well as in strategy design pattern video and adapter design pattern video. So let's try to note down more entities. So in this point, the branches could be one more entity. And in the second point, that is over here, should each branch contain its own vehicle inventory? Okay, so there is no more entity, and over here as well, no more entity. So I hope now you know which all entities would be there. Okay. So now let's check out the class diagram and try to connect those entities and establish a flow for booking a vehicle and submitting a vehicle. This is the class diagram of car rental system. So let's try to understand this by going through each and every component one by one. So let's start with the pricing component. So in the pricing component, as we have discussed, we would be using pricing strategy. So this is the pricing strategy interface, which has a function called as calculate price, which takes 4 parameters as the input. The first parameter is vehicle, because each and every vehicle will have different price per kilometer and price per hour. That's the reason why I have passed vehicle as one of the parameter. The second and third parameter is to calculate the duration for which the particular vehicle was booked. And the fourth parameter is the distance between the source and the destination branches. Okay. And we have two different concrete implementation of this pricing strategy. The first one is distance based pricing, which would calculate the price based on the distance. And second is hourly based pricing, which would calculate the price based on the duration. Right. Now coming to the payment component. In the payment component, again, we have one payment strategy interface, and it has a function called as pay, and it would take booking as the input. So I have passed booking because this booking object would have everything For example, it would have user data plus it would also have the amount which that user would be paying. And we have two different concrete strategies. The first one is card, second one is cash. So this pay function would deduct the amount from the card, and this pay function would deduct the amount through the cash. Now this is the payment processor context. In here we would be injecting the particular strategy that we want to use. So if we want to use card based strategy, that would be injected over here through constructor based injection. And whenever we call this pay function, it would directly call the pay function of this card payment, right? Then over here I have the abstract of vehicle class. The vehicle class has certain attributes which would be shared between all the concrete classes, like sedan and SUV both will have their own license plate, both will have their own model, and so on and so forth. So they have the status, which is the status of the vehicle. For example, they can either be booked, available, or in maintenance. Similarly, they will have their own price per hour and price per kilometer. Then this is the vehicle type, and this is the amount of time or number of time that particular vehicle was booked. And this is the Boolean variable in order to check whether that vehicle is booked or not. And this is not the ordinary Boolean variable, it is atomic Boolean variable. We'll discuss about this in the code part. And in order to create those vehicles, I am using factory design pattern. So I have created one vehicle factory in order to centralize the vehicle creation process. If we don't use this factory, we have to write if else condition in the client class, which would basically violate the solid principle. Now in the booking component, we have the booking strategy as the interface, which has a function called as book vehicle, and it takes list of vehicles as the input. Okay, and this strategy has two different types of implementation. The first one is cheapest booking strategy, which will book that vehicle which is cheapest. Similarly, the second concrete strategy is least booked vehicle strategy, which will book that vehicle which was booked less number of time. Okay, now coming to the brain of this booking system or car booking system, and that is booking service class. And I have created this booking service class as a singleton class because I want all of the users to book through only one service class, right? And that's the reason why I have made the constructor as private, and I have exposed get instance function, which would get the instance of this booking service class. Okay, and this is that variable which is private. This variable is nothing but a booking service object, right? Now this booking service class has objects of branch repo and the booking repo. So if you remember, or if you know, the booking service or the service layer will only handle the logic related to business. All the logic related to data would be handled by the repository layer. So that's the reason why I will be handling all the CRUD operations like add booking, get booking in the repository layer. And the object of this repository layer is present over here. So this is the booking repo object, and we also have the branch repo object. Okay, again it would have the CRUD operations like add branch, get branch, and it would store the branches in the hash map, wherein the branch, this is the branch object and this is the ID in order to access that branch. Same thing is present in the booking repo as well. Now this booking service has two main functions. The first one is book vehicle, which will book the particular vehicle from this branch ID, and this is the type of the vehicle which we want to book. This is the duration for which we want to book that vehicle, and this is the payment strategies that we would be using in order to book a particular vehicle. For example, I can choose cash payment. So here I have to just pass the object of cash payment strategy. Then this is the pickup branch and drop branch and the distance between those branches. Similarly, I also have a function called as return vehicle, or you can say submit vehicle. So I will be submitting that vehicle to the drop branch, and the input would be the booking ID. From the booking ID, I will get all the details, because the booking object will have obviously the booking ID, the user who has booked, the vehicle which was booked by that user, the pickup branch and drop branch, the duration, and the status of the booking, and the actual amount as well. So status of the booking means whether that booking is created or cancelled or completed or confirmed, and so on and so forth. Okay, we'll see this in code. And there is one more class which is branch class. Each and every branch would have the unique ID associated with it and the city in which that branch is present. And this branch class also has the vehicles. Now, in order to store the vehicles, I am using hash map. The key of this hash map is the type of the vehicle, and the value is the actual object of that type. For example, if I just want to get the bikes present in this branch, so I will just query through the map. I will say that give me all the vehicles which are of type bike, so I can directly get the list of bikes. Okay, now instead of using this hash map, you can use enum map as well, because here the key is the enum. And we also have the curl functions in order to store the vehicles or fetch the vehicles or remove the vehicles from this hash map. Okay, so I hope now you understood the entire class diagram of car rental system. So now let's check out the code. So now let's check out the code. So firstly, I'll be showing you the output of our current car rental system. So I've created the branch repository and the booking repository, and there are two branches in our system. So I've created the two branch and added them into the branch repo. And then I have created three different vehicles. Two of them are sedan and one is SUV. And I have created those with the help of vehicle factory. And I have added them into the branch 1. Similarly, I have also created sedan into branch 2. So the branch 1 will have 3 vehicles, branch 2 will have 1 vehicle. And I have passed the attributes like number plate of that vehicle, the per hour rate of that vehicle, the per kilometer rate of that vehicle, etc. Okay. And this is the user which we would be using in order to rent a car and submit the car. And this is the time duration for which this user would rent a car. I have also created a booking service. So this booking service will have the branch repo and the booking repo, and it will also have the different strategies like least booked vehicle strategy. So the vehicle which is booked least number of times will be assigned. And similarly, we would also have this pricing strategy. So currently we are using this hourly based pricing strategy. So I have called this function called as book vehicle, and I am trying to book a vehicle called as sedan from the branch B1. And these are different attributes. I mean, I want to book that vehicle from start to end, and I will pick the vehicle from branch 1 and drop that to branch 2. And this is the kilometer between branch 1 and branch 2. And I would be paying through credit card. Similarly, I have also called this function one more time over here, and all the parameters are same apart from this. So over here, I will be booking through wallet. Okay, I'll be booking through wallet. So let's run the code and see the output. As you can see, the booking was successful both of the times because there were 2 sedans available in the branch B1. and the amount charged was $125 for the first vehicle and $110 for the second vehicle. It totally depends on the rate of that vehicle. So we have assigned different rates to different vehicles. Okay. So those rates are basically used in the strategy, the pricing strategy. So I'll be explaining that algorithm to you while I'll be explaining the strategies. So right now, I hope you understood that two bookings were done and both of them are successful. But now let's try to simulate the multi-threaded code as well. So what I've done over here is I have two threads, T1 and T2, and both of them will try to book SUV simultaneously from branch B1. So there is only one SUV in the branch B1 and two different users will try to book that SUV simultaneously. Then only one of them should get, right? So let's see whether both of the thread will be successful in booking or only one thread will be successful in booking. So here we can see both of the threads started simultaneously, but thread T1 ended unsuccessfully, meaning it was unsuccessful to book the vehicle. Okay, and thread 0 was successful in booking the vehicle. That's why one booking was made. This is the booking ID, this is the user, and this is the pickup and drop time, and this is that SUV, and this is the amount. Okay, so if I rerun this code again and I keep on rerunning the code, you can see that this time thread 0 got failed. Why? Because we are not concerned that which thread will be successful in booking the vehicle. The main thing is if two users are trying to book the vehicle, only one of them should get. It might be user A or it might be user B. I don't care. Only one of them should get. That is what I care. So this is that. So I hope now you understood that our code is also handling the concurrency part as well. So now let's see each and every classes which are present in our car rental system. So let's start with the enums first. So I've segregated all the classes and created the respective folders and put those classes into those folders. So first we'll see the enums. So we have a booking status enum. So first the booking would be created. So when I try to book a vehicle, that time the booking would be created. And when I pay the bill successfully, at that time the booking would be confirmed. And when I submit the car to the drop location, at that time the booking would be completed. And if I was unsuccessful while paying, that time the booking would be failed. And if I change my mind and cancel the booking, then it would be in the cancelled state. I have not added the functionality for cancelled state because the main goal of this problem is to book the vehicle and submit the vehicle. Then comes the payment status. The payment would be initially in the pending state, and if it is successful, then it goes into success state, else it goes in the fail state. Similarly, the pricing strategies are of two types. The first is time based, second is distance based. The vehicle status would be available. Okay, it could be booked. So if I book the vehicle, then it would be in the booked state. Then it could also go in the decommission or in service state. After that, we also have this vehicle type enum, which signifies the type of the vehicle. We have sedan and SUV in our system, but in future you can keep on adding more types. Now coming to the factory, so we have used factory design pattern in order to centralize the vehicle creation process so that I can avoid the if else logic in the client class. Then this is the booking class. This booking class will have all the metadata like booking ID, the user who has booked, the vehicle which was booked, the pickup branch, drop branch, and so on and so forth. So initially when booking object would be created, at that time the status of the booking would be in the created phase and the payment of the booking would be in the pending state. Okay. Later on it will be changed. And I'm using this toString function so that I can print the booking object in nice way. Now let's see the vehicle. So we have this vehicle class and this is the abstract class. It has all the common attributes which I have already explained in the UML diagram. And it also has this increment booking count function. So this will basically increment this total number of times the vehicle was booked in its life. Okay. And the key attribute over here is booked variable. So this is of data type atomic boolean. Okay. So if you don't know about atomic boolean, I would highly recommend you to study about this. So what this would do is it will allow us to book a vehicle and that booking will be done atomically. That is, only one thread will be allowed to change the state. So if it is false, then only one thread will be able to make it through. So if there are two threads T1 and T2, then if initially both are false, okay, both of the threads sees that this variable was false, then only one of them will be successful in converting this from false to true. Why? Because this variable is atomic in nature. So this was the abstract vehicle class, and we also have the concrete vehicle, which is sedan. So all the unique attributes related to the sedan will go into this class over here. Similarly, we have SUV class as well. Now let's see the branch. So each and every branch will have its unique ID, and the branch will also have a city in which this branch is present. And we have some CRUD operations like getting the vehicles by the type. So for that, what I've done is I've used one hash map so that I can get the vehicles by the type more efficiently. And I have CRUD operations like add vehicle and remove vehicle. Okay. So I think I've covered all the classes, and yeah, there is one user class which has this attributes like ID, name, and email. In the booking repository class, also I have this CRUD operations like add booking, which will add the booking into this map of bookings. Okay, this string represents the ID, this booking represents the object corresponding to that ID. So I can add the bookings. Sorry, I can add one specific booking into this bookings map, or I can fetch a booking based on the ID, or I can remove the booking, or I can get all the bookings in the map from the map. Similarly, I also have the branch repository, which will allow us to perform some CRUD operations like adding a branch and getting a specific branch. Now let's see the strategies first. So this is the payment strategy, and it has this abstract function which will be implemented by each and every concrete strategy. So credit card will have its own function. It will simulate the process, and finally it would return true or false based on the output. Okay, if the payment was successful, then it would return true. Now let's talk about the booking strategy. So in the booking strategy, we have this function called as book vehicle, which will take the list of vehicles. And we have two different concrete implementation of the strategy. First is cheapest booking strategy. So in that function, what I'm doing is I am first sorting all the vehicles based on their price or fees, you can say. So first I'm sorting them based on their fees. After that, once they are in the ascending order, I will try to book the vehicle which is at the first place. So let's say thread T1 and T2, both of them tries to book the 0th indexed vehicle. So they will call this compare and set function of is booked. So we are basically trying to convert this state from false to true. So as we already understood that only one of the thread will be able to convert it from false to true. So if there are two threads which are trying to occupy or which are trying to book a vehicle at 0th index, then only one of them will be successful. The one which is successful will return the vehicle. Okay, will get this vehicle. The other which is unsuccessful will go to the first index, and so on and so forth. That's the reason why I am using this for loop. Okay. Now in the least booked vehicle strategy, again we have this function which is booked vehicle, since it is implementing the booking strategy. So over here I am sorting this vehicle based on the booking count. If there are two vehicles and one of them is booked 5 times and another one was booked 7 times, so the one which was booked 5 times would be at index number 0. After that, again I'm doing the same stuff, going through each and every going through each and every vehicles in this sorted vehicles list and trying to book that. And finally, if I was unsuccessful in booking the vehicle, I would return the null. Now let's see the pricing strategies as well. So in the pricing strategy, we have a function called as calculate price, which will take this 4 attributes as the input, on the basis of which we would be calculating the price. So the first implementation is hourly based pricing strategy. So over here, first I am trying to find the total number of minutes, or I'm trying to calculate the total number of minutes between the start and the end time. Okay. And after that, I am trying to calculate the total number of hours. I'm doing that by rounding of the minutes. So for example, if I book the car for 43 minutes, then also I will be charged for 1 hour. Okay, that is 60 minutes. So once I calculate the total number of hours for which this vehicle was booked, so I'm multiplying the total number of hours by the price per hour of that vehicle. Okay. If you remember, we have already assigned price per hour and price per kilometer for each vehicle. So we are calculating that based on that parameter. Similarly, in the distance-based pricing, uh, we already have this distance in kilometer as the input. So I'm multiplying the distance in kilometer with the per kilometer rate of that vehicle. Okay. Now let's see the last two classes. The first one is payment processor, and we already know that we have to inject the payment strategy over here, and we have a function called as pay. So in that pay function, we would call the process payment of the strategy injected. If the strategy is UPI payment, then UPI payments process payment function would be called. If the strategy is card payment, then the card payments process payment function would be called. Now it would return true or false. If it is true, then obviously we would be changing the status of the payment. It would become success from pending state, else it would be changed to failed. Now let's see the last class, which is booking service class. So the booking service class will have the instance, and this is static, okay, as well as it is private. If you don't know why I'm making this private, static and volatile, you can watch my singleton design pattern video. And we also have this repositories. So booking service will be interacting with the branch and booking repository. And it also has the booking strategy and the pricing strategy. And in future, we can also modify the strategies because we have the setter annotation. Now the main functions are book vehicle and submit vehicle, or I've just used this name as return vehicle. So in the book vehicle, first I'll check whether that branch exists in the branch repo or not. If it does not, then I will say that branch not found. Now I know that this is not the good way to write the code. Instead, you can use your custom exceptions over here. Like you can create a class called as no branch, or you can say branch not found. Okay. So you can create your custom exceptions instead of doing this, but I have not done that because obviously this is just for explanation purpose. But in interview, you have to do that. Then once I check whether that branch is available or not, I will try to filter out all the vehicles which are available. Okay. I will get all the vehicles by the vehicle type from that branch, and I will filter the vehicles which are not available. Okay. Because some of the vehicles are maybe in the servicing state, or maybe they are in booked state. So I will just get those vehicles which are available. Okay. So once I have the active vehicles, if the active vehicles list is empty, then I will print this message that is no active vehicles available. And if I have active vehicles, then I will call the book vehicle function of this strategy. And we already discussed the booking logic. Okay. And we were handling the concurrency in that book vehicle function of the strategy. So if one thread was successful in booking the vehicle, that thread will get this vehicle. If that vehicle is null, it means that that thread was not successful in booking any vehicle. So that would be null. And in that case, I'm printing this message, which is no vehicle could be booked. And if it was successful, in that case, I'm trying to calculate the amount using the pricing strategy. And finally, I'm trying to create the booking object. Okay. So once I create the booking object, I would process the payment. So this is the payment strategy, which is given by the user in the input. Okay. So I am injecting that payment strategy into the payment processor, and processor will call the processor.pay function. So it will be either successful or failed. If it is failed, then I will be printing this message, which is payment failed. And by the way, here I will roll back the state of this booking. I will make it to false, because in this function, in the book vehicle function of the strategy, if you remember, we converted that to true over here using compare and set function. But now if the payment fails, I have to roll back. So that's why I am rolling back. Okay. But if the payment is successful, in that case, I will change the booking status to confirmed, and I will also change the vehicle status to booked, and I will increment the booking count of that vehicle. Okay. So this was the book vehicle function. So now let's see the return vehicle function. In this function, we would be returning the vehicle to the drop location. So first we have the booking ID as the input. So I will get the actual booking object from the booking ID using the booking repository. So this is that booking object that we got, and I'm doing some checks. After that, I'm trying to convert the status to completed, signifying that the booking is now completed. And I am making the is booked variable, which was atomic, to false. And finally, I am adding the vehicle into the drop location. So that's it. So I hope now you understood the entire car rental system. If you did, please like the video, subscribe to the channel and share this with your friends.